Okay, I just wanted to quickly do a help video for a couple of the questions, the homework questions in this assignment. I'll open it in a second. And then once I record this, I'm going to also place this video you're watching right now here in extra videos for future generations. But for now, I'm going to post this as one of those announcement recorded Zoom videos. And the questions I want to help you with are the last couple here, these two. Okay, I'm not going to do the whole thing for you, just want to get you started. So here's the first one. So we've got here x is a function of y, and you should remember from pre-calculus that that's going to be a parabola that points sideways. And we've got this fixed point 6 comma 0. And we want to find the point on this curve that is the closest to this point right here. Now we could see from symmetry, there are going to be two, one like right in there and another one over here that are the same distance. And the question's not very clear on the directions. They mean this guy, the one up here with a positive y value. That's what I know because I've looked at the answer. So when you solve, you'll get two different y values, plus and minus the same number. You want the positive one. Okay, so what we're going to do is we've got this curve here. I'm going to think of this guy as x equals y squared over 8. Then this point here, if you pick a certain y value, the x will be determined. So you pick a y value, the x that goes with that will be that y squared that you just picked over 8. Then we're just going to use the distance formula. Distance between any 2 points is just change in x squared plus change in y squared, and we take the square root of all that. We're going to write this as a function of that y value. So my x naught, y naught is just this fixed point. My x1, y1 will be this point here that we've written in terms of some y value. So you're going to write out d of y is some function of y. You shouldn't have any x's left over, just y's. And then the way we always find a minimum, always set the derivative equal to 0 and solve. Now, theoretically, we could have places where the derivative doesn't exist, but that won't happen here. In this case, for any y value you can think of, there's going to be a distance between this point and that point on the curve that has that y value. So this guy will always be defined. We just take the derivative, set it equal to 0, solve for y, then once you get your y, get your x. This is a very similar question here. So pause, read the question. I hope you've done that. We get John here, who starts 174 meters north of the goal when he's running down. Liam starts at the origin here and he's running east. That says Liam there. I know it looks like 4 a.m. So we're going to write John's position as a function of time. Everybody here is going to be functions of time. Notice here S of t. That's going to be our distance between the two guys at time t. So John starts at 174 and he's getting 2 meters closer to the origin every second. So at time t, John has moved down to this new position. In fact, if we write that as a point, that will be the point 0, comma 174 minus 2t. Liam is running just east, so he's only increasing his x value. His y value will always be 0, and he's running at 5 meters per second. So at time t, he's moved 5t meters to the right. There's his new point. Now we want to write down the distance between them at time t. So we're, again, just going to use distance formula. Change in my x value squared, change in the y value squared, take the square root of the whole thing. Then to figure out when they're the closest together, we want to minimize distance. So take the derivative with respect to t here, because that's my independent variable. Solve for t, get your answer. Okay, hopefully that helps you with these. Stop recording.